Okay, I'm Hayden McCall and going to moderate the session today. I run iStart Technology and Business. Thanks everyone for attending today. Just quickly, as I said, there's a few more still joining today. We will be recording, so we'll send you out a link to that. You can, no need to keep your notes up to date. You'll get today's presentation and audio and a link through tomorrow. I'm very keen to hear from all of you with questions. Panels going to have a bit of time at the end to answer those. We'll be going through a set of questions for discussion. Each one of them will lead off with that as we go through it, but we should have time at the end to address your questions. So do get them in. You've got some experts at your disposal, so please make use of that. We'll aim to wrap up within the hour. Okay, so today's panelists, Kieran Stokes and Ronaldo Silva from a division of Fisher and Paykel called Faction, just recently set up. It is their manufacturing division underneath the appliances, so they've been around for a very long time, but just created an identity recently with the acquisition from Hire of Fisher and Paykel. They've decided to set up a separate unit. And Simon Boyd from Hamilton Jet, long-established New Zealand-based manufacturer but exporting all around the world. So g'day, guys.
Hello.
Hello, Hayden.
Hi.
Okay, so you guys just, Kieran, if you could lead off with a little bit of an introduction of Faction. I've bunged some slides in here for you to talk to, but over to you to kind of give a little bit of an intro on who and what Faction is.
Yeah, sure. I think you touched on it quite nicely. Yeah, we started off as a subsidiary business to Fisher and Paykel appliances back in the 80s. Core business was really in creating production equipment for appliance manufacturers. So we've got a rich history. Really over the last sort of few years, there's been a big pull to sort of offer more than just machinery. So
Kieran, you're just quite quiet there. Just if you can just speak up or closer to your mic.
Sorry, I'm not closer. So yeah, we've really had to broaden our scope a little bit to offer not just a physical solution for these factories, but also a digital one. So we've moved into sort of industrial IoT and SCADA solutions as well, and really offering that overall factory solution. So yeah, my role in particular at Faction is industrial IoT solutions architect, and what that means is really just ensuring that the digital solutions that we are creating and implementing are done so in a scalable and future-proof manner. And I've worked with Ronaldo's team, the software products team, very closely, and I'll let him sort of explain a bit more about that department.
All right, good stuff. And I think just a little bit of an overview of the things that Faction gets their hands dirty on. Let's talk to that.
Yeah, sure. So yeah, that's basically along the lines of what I was explaining. So yeah, equipment was really that's where we come from. We've been doing that for quite some time, along with robotics as well. And that factory management and performance piece is really something that we've really been stuck into for the last few years, and service and support is obviously comes with all that as well.
All right, good stuff. Thank you. Okay, Simon, just give a little bit of an overview of your role and what Hamilton Jet's about.
Sure. So Hamilton Jet, for those that don't know, we're a marine water jet propulsion manufacturer, one of three major manufacturers in the world. Although there's about a dozen in total, there's only really three that dominate the market. All our manufacturing is based in Christchurch, about 300 people here, and we have sales, distribution, service offices, USA, UK, Singapore, and a distribution network around the world. We're a vertically integrated manufacturer, and Hayden, maybe if you just want to flick on to the next slide. Yeah, so there's a few stats about us to start with. We produce anywhere between 1,800 and 2,500 water jets a year. 98% of those exported, and we're up to around 60,000 units installed worldwide. Our jets go in vessels from 4.5 metres to 70 metres long. So while a lot of people will be familiar with the shot over jet or river boats in New Zealand, most of our product is much bigger than that, going into big work boats overseas. and then just onto the next slide, if you would, please, Hayden. So in terms of our business, we're a very vertically integrated manufacturer. We start with raw aluminium and stainless steel ingot, cast that, as well as having about 25 CNC machines to manufacture all the other parts, on two main manufacturing lines that are loosely split between small and large water jets. We run lean manufacturing principles, so we don't stock any finished product, and all jets are made to order. Nothing is made for stock. All of those jets are configured, which I guess is the relevance of today's session. So every jet is configured from predominantly a standard range of options depending on which vessel they're going into. Systems-wise, you'll see there we have two main systems. Windchill PLM for managing all of our CAD data, which is the driver behind everything we manufacture, and Infor M3 ERP, including their configurator. You'll see the other stuff on the slide there about our processes, a lot of different processes to manage inventory. We have a lot of long lead time material that has to come from overseas. A lot of our raw material is purchased in and is very long lead time, anything up to 6 or 8 months.
All right, excellent. So good stuff. I mean, today probably Ronaldo and Kieran coming at it from a multi-site kind of probably theoretical best practice, leading trends, and then we're going to bounce it back to Simon in terms of what that means, sort of factory floor, and apply it into the scenario of Hamilton Jet. So we'll get into on Hamilton Jet as we go through. All right, so yeah, 7 questions, and Kieran on the spot to lead off, but do please raise questions as we go through. Now, we had Henry Ford as the theme in the promotion around this, so I thought just to help you get going with the Q&A, if people can have a stab without cheating at how many Model T Fords were manufactured by Ford over, I think it was 1908 to 1927 when the production run was there. Have a crack at that, send us in as a question, that's fine, and I'll keep an eye on that. I've got a chocolate fish that will go to the person that gets the closest. All right, Kieran, what are the key trends emerging? So I guess paint us a picture of what this advanced manufacturing idea is. Obviously industrial, sort of Industry 4.0, IoT, lots of noise and things going on around that, but give us, maybe paint a picture of how you approach what that looks like.
Sure. Yeah. There's a lot of buzzwords flying around at the moment. I guess there's sort of those key themes that you hear going around. Movement of mass production to mass customization, and this customer-driven production and whatnot. But what does that actually mean, and what are we doing different in manufacturing now? What are we improving on? I quite like to start with a little thought experiment. And sort of thinking, okay, well, if I could live in a world where everything I could imagine could be real, what would manufacturing look like? And it probably wouldn't look like manufacturing at all. It'd probably be something in the realm of, I have a shopping experience that is with augmented reality or virtual reality. I touch and feel and see my product that I want to buy, my chair. I say, yep, that's a nice looking chair. Push order, and it teleports into my living room, and I go and sit on it. That's probably the ideal situation. Is it possible? Well, not in my head, and probably long after I leave this earth. So probably not worth talking about anymore. But you can sort of peel back from there, right? And you can say, okay, well maybe we're not going to go quite that far. Maybe it's more like let's take your local dairy, for instance. Rather than a local dairy, you have a local manufacturer who can manufacture anything in the world. Okay, so it's absolutely really smart and flexible machinery. And then the suppliers can, they can send their recipe for their product. They can encrypt it so it stays, the IP stays with them, and they can create this product right next to you, and then you go and pick it up, or it gets delivered to your door. It's only 100 meters down the road. Does that get a bit more believable? Yeah, perhaps, but machinery is a long way from being that flexible. And then maybe you move sort of into closer to what we are now when you come back even further and say, okay, well, maybe we're not that flexible, and we do have to have still, specialist manufacturing facilities. And then you have to get a bit smarter with how you cut down that lead time, right? So maybe I don't know, you bring in Twitter and Facebook feeds, and when Kim Kardashian likes a particular chair, well, then you know that the demand for that's going to go up and whatnot. I don't know, my imagination is probably not as good as other people's imagination out there. But wherever you sort of sit on that scale of where manufacturing is going, I think there's still some common elements to anywhere in that scale as far as direction as to where we're going. So smart machinery, I mean, that's something that we're always going to have to improve. Machinery that can talk and interact with each other and things and people. Flexible machinery that can make many different products, not just one product. You can make a keyboard and a chair and a remote and whatnot. Data, we're really close with this one. I mean, this is probably the one where we're furthest ahead of. If we're furthest behind in flexible machinery, we're probably furthest ahead with data. We can move it, and we can collect it at scale, and we can ingest it at scale, and we can do all sorts of things with data. More important than data is information. I find it quite amusing how people, there's such a buzz about data. Everything is about data, and I find it kind of similar to everybody talking about the wheels of a car, and saying that, the wheels of your car are so important. Like, yes, but the car is actually pretty important too, right? And that's how I sort of view data and information. The internet, that's obviously a big one that's changing too. So the likes of these IoT networks that we're seeing come out, 5G, which I think is due to go in 2020, that they're going to have a big part to play. And of course, applications and their integration abilities. So modular applications. So that's the other key, is that applications, there's no longer that one platform to sort of rule them all, gone are those days. I say that, and yet SAP implementations are still going on all over the place. But the whole idea is that, it's that interoperability, and I think these terms that are around, like the Industry 4.0 and Industrial Internet, these are the things that they have in common with each other: interoperability, modularity, and decentralization, and all of these things. So I think the things that we're working on are pretty clear. Where that might put us, and whose initiative is the most accurate. Is it Germany's Industry 4.0? Is it America's Industrial Internet? Is it China's Made in China 2025? Who really knows? I think that's sort of just the end of the ride, and at the moment we're just sort of enjoying the journey.
Okay, it's a good painting a picture, I guess. So next one is for you, Simon, is to sort of say, given that as a backdrop for your environment, what are you seeing as being the key things that you're close to moving on, or already running pilot systems around, and where the value is?
So there's a lot of different points that Kieran touched on that we're either actively doing something about or close to doing something about, and that ranges right from fast prototyping of product now, where we're using overseas-based suppliers and shipping, large CAD models or CNC programs, whatever, over to them so that they can do rapid prototyping with large 3D printers, that type of thing, through to what we're actually doing on the shop floor with our machinery and trying to apply IoT principles to quicken cycle times, and then on through into service and support of the water jets when they go into vessels. Again, we're working at the moment on systems that we can remotely monitor, if the customer so desires, the performance of the water jets on the vessels, and remotely diagnose problems with either the water jets or our electronic control systems that we manufacture as well. So we touch on it in lots of places. If you bring it back to core manufacturing, and one of the keys for us is we deal in an environment that can work with quite long lead times, a lot of product variability. We have 18 to 20 models of jet, and as I say, each one's configured for the order, so you don't know when an order starts to come in how it's going to be configured. That creates a lot of challenges around planning materials, demand planning, lean manufacturing, scheduling, all those sorts of things. So anything that we can do using those technologies to shorten those timeframes, even thinking about blockchain and communicating with suppliers overseas, supply chains in that respect, to bring product in. So we're very heavily technology dependent in that respect. But predominantly at the moment, the focus is around shortening up the supply chain cycle so that we can meet customers' demands and supply the right product on time.
So you talked about this prototyping of sort of early versions of things, shipping that off to someone else to do that. How far away are you from doing that sort of stuff yourself? Or, I mean, you're running a full foundry. It's the ultimate 3D. Yep. Is it ever going to be anything different than that? I guess you've got molds to manufacture every time, so there's a cost of change out.
Yeah, there is. But what we do with a lot of our rapid prototyping is we actually use some 3D printing technologies. I mean, there are 3D printing technologies now for metals. None in New Zealand, hugely expensive, so we use overseas-based organisations to do that for us. It's not inconceivable that as the price of those things comes down, we will look to bring that in-house. It's cost prohibitive for us at the moment. We are just embarking on the development of a new range of water jets, and so this is becoming front and centre right now. But yeah, it's certainly a lot easier now, just in the fact that you can take a 3D model and from it create the machine code or the printer code to do that work. That's one of the big advantages for us now. You don't have to have the same number of programmers taking those drawings or CAD models to create the machine code to actually run the machines.
Yeah, interesting. Okay, so on to the third one, to bring you in. Ronaldo, you've been sitting there quietly, and I see you've got a colleague along for the ride. You might want to introduce them as well. We're talking about configurability, and there's a little bit of a theme around Henry Ford's, any colour as long as it's black, being maybe old thinking that now very much changed. When you introduce configurability, what complication do you introduce as a manufacturer?
Hello. So yeah, I'm here with Gil. He's our project engineer for our core machinery business. So it's good and bad, right? And of course, this has been always a challenge. And I think it's in terms of the cons, it adds more complexity to how you can achieve a lean manufacturing process while you are trying to have a customized process to deliver a production of an item. I think that's the cons that we have there for this. I think the way that we are looking at limiting that, I think we should be looking at how to build and that's what the technology we have today is allowing you to do, is that you can have the likes of machine learning, you can have the likes of understanding about patterns and behaviors, to have a way to automate and know exactly what do you actually need to deliver a part. So today's you are all about, we have two streams, right? We have the ability to do a mass production, and then you have the made to order production, which is highly customized. But then if you want to be involved, like the complicated part for being the mass production is that you can run more, at a higher scale, mode. But then for you to be able to deliver a customized part, you're not able to do it. Not at the time and the cost level. And once you run a customized one, you are very limited to the quantity that you can do. So the way that we are doing to kind of enable customers to do that, we are looking at two things, and they're all based on leveraging the new Industry 4.0 and all the industrial technologies. So one is we kind of understand about the challenges and help them to understand that it's really important to still be very lean manufacturing focused in order to be part of both and use both mass production and also what we are calling now mass production of a single batch, right? So you can have still a customized washing machine with the buttons in a different size and all that, and you can produce that at the same time, same lead time, by learning how you can use the software to identify in between runs of the mass production, you can run batches of customized products just based on what the software can identify. So, for example, let's try a different example. If Simon, for example, is running a mass production of a jet for a large customer in the US, hundreds of them, but there is a large order of one single piece, one batch of a different model. The technology can help by in between shifts of mass production, identifying exactly what sort of materials I have right now on my production lines, and based on that, the order that I have received via my ERP system, what can I do in between running this shift, the next shift? If I have the materials, you are able to use that gap to have everything being loaded in the machine and produce that specific batch. So it's all configurable in between mass production, and we're calling mass production for a single batch of one. So that's all being possible today because of how the technology is evolving and combining internet to your production line, combining machine learning, combining software. We still have to stick with some specific standards in the industry, but I think if you base yourself on the new standards of being lean manufacturing and being knowledge about what are the standards and what can be done with technology, I think it can be achievable. And you can educate also customers, you can educate your manufacturing teams as well. It's all about, that's why it's not only about the technology, but it's a cultural change. It's a process. You have to standardize your process at your end, but it's achievable if you combine all that with today's technology as well.
Okay, guys. Machine learning to me is just something that people just bandy out and put in there, and it's sort of assumed that there's some intelligent sort of thing that you ask a question that remarkably gives you the answer that's going to be much better than the answer you would have come up with for yourselves. But perhaps you could give some examples, Kieran, Simon, where you've seen applicability of machine learning in Ronaldo as well. Specific stuff that the audience can kind of get their heads around, the types of things where machine learning can add some value.
So I'll jump in here. I think an obvious one is statistical process control, which you see quite often in a lot of manufacturers, and being able to leverage those technologies is basically just giving it the next level up, so to speak. So rather than basing if we say we've got some sort of measure station that's measuring the quality of a particular product in the line, rather than going off some set in stone rules, statistical rules as to when that product is going to be violated. So the way it's worked in the past is you can have statistical rules such as Nelson rules, for example, that will tell you when a particular product is trending out of spec. So it's not yet out of spec, but it's going to be out of spec. These rules, for example, look like 6 points in a row increasing or decreasing, right? If you're getting 6 products in a row that are trending in one particular direction, then you may want to create an alert or an alarm to then act upon that before your product goes out of spec. Machine learning can really take that to the next level because you don't actually have to define the rules themselves. Machine learning can define the rules for you. So instead, you can look back at your historical data and using machine learning, you can say, okay, where are these patterns? Like, when are my products failing? And you can bring in more inputs. It might not just be the inputs of the measure station. Maybe you bring in the inputs of something upstream, right? All of this, I mean, that's an awesome, I guess, benefit that we're going to get in the very near future. And then we've also got things along maintenance. Predictive maintenance is the one that everybody talks about as well. So, predicting when a machine is going to fail using the same sort of methods.
Simon, anything to add into that?
Yeah, I mean, maybe not so much directly from the manufacturing side of it, although what Kieran has said certainly about the process side does have a lot of applicability to a number of our processes. One in particular I can think of, an example from a couple of years ago where we had a problem with the paint process, and it took a couple of guys a very long time to get to the bottom of that, whereas if we'd had those type of machine learning processes in place that Kieran's talking about, it would have been very quick, because we would have been able to assimilate all the data and understand the trends a lot better. I'm not sure if this quite fits into the same category, but one of the big technologies that's again, it's a buzzword at the moment, is autonomous, and we're currently working with a number of overseas autonomous control system manufacturers to integrate with our control systems on water jets, so that vessels can be out completely unmanned. And it's not, the technology's there, and they've been unmanned boats for a lot of time, quite a long time. But where we're getting to now is the real level of machine learning that is within these autonomous systems, and how that integrates with our control systems around, self-avoidance, figuring out obstacles in the water and what to do in certain situations, all those types of things.
I'm waiting for one to come out that can the family farm with a kiwi fruit orchard that can send the tractor out to mow the whole thing without anyone getting involved and not getting sort of sweating in the background.
Yeah.
Okay, so Kieran, I guess it's just extending really the conversation that you've already had, but maybe thinking about it from the perspective of client sites that you've been on, where things have been implemented and there's been some real wins on the board. Where do you see that space? What's the sort of laser focus that people should have in this area? And talking specifically in that data engineering as opposed to the physical engineering space and IoT, where you're into this.
Yeah. I think, I think the benefits are sort of an endless list. I think it's every customer has their own challenges, and then every customer is going to benefit from a different solution, basically. So I don't know if there's any sort of one benefit that stands above, but I think if you sort of think of what the main goal of data engineering in industrial environment is, and it's really to provide you with more knowledge and more wisdom in a way in which you can immediately act upon it. Right? So that last part's really important, because I think what we sometimes forget is that knowing more is nothing new. Data science is nothing new. I mean, even machine learning and deep learning have been around for 30 years. They're not new, even though a lot of the time they're spoken of being sort of extremely recent technology. What is new is the availability of these technologies to the common business. And they're not just available, they can actually be integrated into all of your real-time applications. So this goes back to what I sort of alluded to in the first question, was really data is not the important thing. Information is the important thing, and it's real-time information. It's getting a historical look at your data in less than a second. That's what is new, right? So I should be able to look at the value of a temperature sensor, for instance, but I should also be able to see the average of that temperature sensor for the last 3 years. It should take me the same amount of time to do that. So yeah, I think that's really the main point that I'd sort of like to get across with data engineering, and what it's bringing new to us now is really real-time information, and using the likes of machine learning and deep learning, AI, and other data science techniques to do so.
So I guess implementation of sensors and then making sense of the sensor data that it's producing, and filtering that so that you get a sensible data points that then join with other points in your information stream or your value chain.
Yeah, nice pun, by the way. But
yeah,
I think obviously, and this is one point though we've got to be careful not to get out of hand, is that we can put sensors on everything now, and we can get data from from everywhere, and that's the only reason I sort of harp on about the information, is because you can obviously have, you've probably heard the saying, data rich and information poor.
Mm-hmm.
You want to make sure you don't get into that situation. But yeah, as far as sensors, yeah, there's some fantastic things coming out. We're now transitioning from this is another movement, I guess, is rather than having sensors traditionally were part of your control system, and we're sort of taking that out now, because there's no need for a lot of these sensors to be part of your, say, your PLC, your control system of your production lines or your factory, and sensors themselves can be used purely for a data perspective. And so sensors are now smart; they can connect directly to the internet. So yeah, that's another cool benefit that we're making the most of now.
Could I just jump in there for a sec, Hayden? I mean, you know, again, just looking at it from a practical application for what we do, because we do cradle to grave service on our water jets, the sensor technology and the ability to link events and get back to root causes is becoming really big for us. So if for example, we start to see a failure in a particular type of casting for a particular size water jet, well, the ability to quickly go back and see what the temperature of the metal was when it was poured, was at the root cause, and then be able to quickly and easily link that to all of the other parts that were manufactured around that time to see if we're seeing the same sort of failures in parts that were manufactured from that same batch of metal. I mean, all that stuff's doable now. It's pretty time consuming. And again, coming back to what Kieran said, it's the data's there, the information isn't, and it's being able to assimilate that and get results out of it quickly.
So accelerating that whole, decision human, to having the data available if you can use a human brain to solve the problem.
Yeah.
Okay, so I guess drilling down into, and Ronaldo, sort of software dude in the room, and ERP and MRP systems obviously been around for a very long time, but we've got all of this data now flowing. How do you, and how well are those systems equipped to handle the IoT and sensor data? Is that something that's been integrated directly into your sort of core systems, or are we talking completely separate data warehouse and machine learning kind of environment that need to be established around those? How does that all fit together?
So yeah, it's being actually at the moment, what we could see so far is that the manufacturers, they are still using different systems across their operations, and that have been a part of a challenge they have, to implement industrial IoT and all the new standards that we have with Industry 4.0. And you can easily see manufacturing running 4 different systems plus Excel spreadsheets all over, and that's being a limitation for them to be able to take advantage of all the automation they can have with industrial IoT. I think it is important. It's an important part of the business. You have the inventory, you have the financials, you have everything that must be integrated as part of running a business. I think what manufacturers should be looking for is a way to have a solution that can integrate all this system into one, and that will allow them to have a single source of truth, a single interface where each of their departments can use based on a lean, standardized process that they can run their operations in one system. We are doing something in this space. Our product is the only one that's the all-in-one industrial IoT product, and it pretty much does that. It integrates with any existing ERP system, any existing manufacturing system, and give this single interface, and they can do everything in one system, available in all devices. The results so far have been very good. We've got one customer in New Zealand already trying that, and it's been good to see that the actual maintenance, the factory workers, they really like it because it allows them to spend more time where they want and they like, which is very much in the factory floor. And then you walk on the office, you no longer have that control room where you have multiple systems. You have everyone around the business with laptops or iPads, just run the same interface, and which of course is easy to use as well. Because once you think about ERP system, you're thinking about the big players where they have the same system being highly configurable to so many verticals, where you actually have to almost be an expert in developing field configurations and all that, and you have like multiple screens and all that. It's kind of difficult as well for the lean manufacturing as well. So I think it's definitely one of the many challenges that manufacturers will face, and we have to overcome to become an intelligent manufacturer. And I think technology can help with that as well.
And how about on the demand side? You got all this information in terms of, right out to customer sentiment. You touched on sort of Twitter feeds and things feeding into this stuff. To what extent is the data engineering driving demand that drives your planning cycle through into your inventory and manufacturing planning processes? Is that all part of the picture?
Data engineering. It's very much based on demand from customers, from sales, that drives the whole cycle. So the idea, the big picture, the big vision, is to be able to connect the actual end customer with the factory, being part of the process of having the product being designed, built, delivered, and then supported. That's the big vision. It's all at the moment driven by demand from the end customers or the suppliers that you provide your products. And then the data engineering part, it's part of the manufacturing execution system that should be adapted to that demand. Because at the end of the day, you really have to have a demand, or your products should be able to have the need to scale your systems and have a lean manufacturing process and have all technology behind that, make things more possible, more cost effective. So I think more like driven by demand from the actual customers.
Simon, maybe talk a little bit about how all this works in your world, your sales and operational planning process. You mentioned very difficult to plan ahead, major capex investments that your customers are making, and also looking for specific capability on the water. But just talk to how that feeds through and how you kind of forecasting and planning on the demand side. How does that translate to what you need to do in your manufacturing environment?
So there's a couple of things. One is the time required. So although we manufacture what we consider to be an end product, it's only a component of a vessel. So we are very much bound by when the water jet needs to be installed in the vessel as it's being built. That becomes a non-negotiable that we're measured on, and if we miss those deadlines, then it has fairly serious consequences for ongoing relationships with customers. The flip side to that is if customers want water jets in a very short time frame, and we've already got a reasonably full manufacturing schedule, it's how do we juggle that all around to make that work for everyone. And I think that, again, that's where some of the smarts that are coming at the moment can assist us with smart scheduling, smart planning solutions that can very quickly and easily look at all the permutations and combinations of how we can manufacture the demand we have to meet all those requirements. And if we can shorten that time frame up, then there's not so much of a back and forth negotiation with the customer, whoever the customer is. In our case, the customer can be one of 3 or 4 different parties. My ideal in a perfect world would be for the customer to be able to sit down with one of our guys, pull up a screen, put in an ideal delivery date and what the likely configuration is, and the system straight away, yes, no, it can do, or it goes away and thinks for a couple of seconds and reschedules everything in the factory to see if it can achieve that. And then on the back of that, check material supply from our own overseas suppliers to make sure that we can bring material in time to make that build. So it is really just about shortening that whole the time cycle around that whole process.
And so you're still in an environment where there's quite a lot of human intervention required to come up with an answer for that order.
Yes, yeah, we are. I mean, we're working towards the more automation, but dealing with many hundreds of suppliers around the world, it can be quite challenging.
All right, good stuff. Kieran, anything to add into this one?
Yeah, I'm just going back to the original question of what's the state of that customer-facing side solution. And yeah, it is probably a bit further behind, I think. And Simon, I guess you've touched on this a few times, right? It's that value for money too, as well. I mean, a lot of the gains that you can get in the factory, they're the low-hanging fruit. They're just sitting there. Whereas the customer-facing staff and demand-facing tools, yeah, they're going to give you value, but as Simon said, there's probably quite an expense to doing a lot of that stuff.
All right, well, that dovetails perfectly into the next question, which is getting towards the end. We've got another one at the end, which is a little bit of a wrap-up. But audience, we've had some noble attempts, but no on the marks in terms of the number of Model Ts that were produced between 1908 and 1927, which was the whole production run. There's no trick question in that. But also questions that you've got, whether they're specific to your own environment. You've got a team of experts here to address questions. Please get them in the Q&A pane. We'll have time at the end, so fire away as you're listening. So, Simon, your role also CFO as well as CIO. You've obviously got some of the dollars and cents around these initiatives, and really this is where the rubber hits the road. How do you go through kind of running scenarios as to what's going to? Oh, hang on, I've bounced forward. But there you go. How do you? What's the kind of, I guess, scenarios you go through to assess value and what you're going to invest in?
Yeah, so I mean, as I said earlier, while we've got a wide range of water jets with many configuration options, we try and keep our manufacturing at around sort of 90% standard options. So although each water jet is configured, it's configured from a list of standard options. Now, again, in this day and age, that's not going to suit every customer, and so we have a reasonably rigorous process to assess what the customer is asking for, and whether what they're asking for could be applicable to other customers, whether it's a feature that we should look to integrate into other water jets, and if it is, what is the cost of the engineering design around it, and possibly any other equipment around it. And it's fair to say, I think probably in the last few years, the focus has been less around the actual mechanical side of the water jet, and it has actually been more around the software side of the control systems that integrate with them. What can we get these cool new electronic control systems to do with the water jets, to make them perform better, make the vessel perform better, give us better feedback, lots of things around that. And so that comes down to it's a good analysis of what is the time going to be to develop those versus what's the likelihood of us being able to sell it again. And we go anywhere from asking a customer to fund that NRE, the non-recoverable engineering, 100% to 0% if we think it's something that we can we can sell many units of, and each one's assessed on its own merits.
I guess you've got third-party suppliers involved in there as well with software engineering and
well, we do all our own software engineering. What it comes down to is more again, one of the challenges for us is because we're a low volume manufacturer and we're dealing with a reasonably large number of electronic modules. It's more around PCB manufacturer and convincing PCB manufacturers to do low volume runs for us. Yeah.
Okay, and so in the Fisher and Paykel world, Kieran, maybe talk to that a little bit. I guess much more scaled up and high volume manufacturing to an extent. I don't know how you define that, but what's your experience in this space of the processes you need to go through to justify investment?
Yeah, it's yeah, it's a good question, and normally I guess I'm on the end of selling the solution as opposed to as opposed to purchasing it. Um, but yeah, no, it's really important. I think just being thorough with your analysis. There's a lot you can do now, especially with the factory automation side of things, and predicting what the benefits you are going to get are going to be. And I think take those opportunities when they're there. If you can calculate the costs that you're gonna save, definitely do that, and you can weigh up how much it's going to cost versus what it's actually going to cost you.
Yeah, yeah. You raise an interesting point, though, that often it is the innovations coming from people who are trying to sell these systems in to have them included in your products, right? I'm pretty sure that was the point you're making.
Yeah, definitely. I think that's actually a really good point. It's we have to be really careful as sellers because it is really important to make sure that it's the whole business pull versus technology push argument, right? Like that business pull is really, really important. So that's why we love our relationship with Fisher & Paykel Appliances and any of our other customers, and we use it not just as a place to put all our technology, but as a place to learn, to enable those business pull opportunities to come our way and really dictate what we're providing.
Yeah, excellent. All right, so let's just move to maybe just a wrap up in terms of the key points. I've kind of steered things a little bit. So just from your own perspectives, what's important and what do you think you wish someone had given you the advice when you set off down the path? Maybe Simon, you can lead off with this one in terms of, the experience that you've had in this space.
I think I'll probably sum it up in the old 6P saying: proper planning prevents poor performance. It's about being flexible enough to allow for new technologies to be implemented as they come on, because we don't know what we don't know. So there's always going to be something comes along that we think that would be great if we could implement it. So you have to understand your processes, understand what the current scenario is, current manufacturing environment, but have some idea about where it might be going, and just be open and flexible in terms of looking at how it can benefit you. It's as much as I like technology, it's not all about the technology. It's about what it can do for cost reduction in terms of getting product out the door, or speed to market, or customer satisfaction, all those other things. You really do have to have a look at to me, the whole picture of what you're trying to achieve. For us, we're a niche manufacturer at the bottom of the world, where 98% of our product is exported. So cost is obviously a very, very big focus for us. People continuously ask us, why haven't we taken our manufacturer to a low-cost country? And the answer to that is we can't get the quality that we desire. The downside to that is we tend to pay more in labour cost in New Zealand than we would if we did take it somewhere else. So you've got to look at why you're doing what you're doing, where you're doing it, and what's important to you in the long term.
Ronaldo, your perspective.
Good as well. Yeah, very good point, Simon. The other thing is also having that lean manufacturing thinking, right? Because there are lots of challenges. But I think the most important thing is to be aware of what are the challenges, what are the options, and have the lean approach to things, where take steps to just break down on all the challenges we have, and then just step by step, you do the foundation for specific challenges, and then iterate over time. Because most problems that we have when we have manufacturers fail in terms of integrating new technology to their process was that they try to do all at once, try to solve all the problems at the same time, and then they just realize so many unforeseen issues all together, and then they just say, oh, it's too hard, software is too difficult, let's go back to business as usual and do as we are always done. So the idea is be a lean manufacturing thinking, be knowledgeable about what technology can bring to your manufacturing business today. Read about Industry 4.0, Industrial IoT, and take steps towards that. Break the challenge into small pieces, iterate over time. I'm very sure that over time you'll be able to achieve, improve, focus on the quick wins, show value on what the path you're doing, get feedback from your customers on things that are being improved, what they think about, and then go to the next step. Over time, you'll definitely be a better manufacturer and be an intelligent manufacturer as well. That will be a main take.
That's agile principles, right? Both from a software engineering, agile with
exactly,
but also organizationally.
Exactly.
Yeah.
Exactly.
Hey, Kieran, what's your perspective?
Just to elaborate on actually what Simon touched on around that flexibility and in particular flexibility to adopt technologies. I think we're in a really vulnerable position at the moment. Reason being there's these I guess vendors and companies that have sort of dictated technology in industry for the last 20 or 30 years. And now what we're experiencing is this convergence of IT and OT, information technology and operational technology. And what we now have available to us is all this technology from the information technology side, but you have these vendors that still sit in the OT side of things that are providing products that are not industrial IoT and Industry 4.0 ready. They don't follow those principles of modularity and scalability. They're extremely overpriced. We've got to be careful that you're putting in something that's future-proof and is not going to come back to bite you in the bum, so to speak. Right. So just that would be, I guess, my key takeout is to make sure what you're putting in and what you're purchasing is future-proof and scalable. And my only other thing that I see as a really key point is, and we've said it many times in this webinar, is that adding value part. Don't do it if it's not going to add value to your business. Don't get carried away with the buzzwords and just do what's going to make sense for you.
Yeah, I'd jump back in and just completely agree with that. I think the whole thing, even looking at the ERP systems, is going from the monolith spec to now much more modular systems, and the whole world, the way the world's going with apps and all of that sort of thing. It's very easy to build an app now and add it on to whatever you've got if you've got a good middleware engine that can handle it, and that's the key. It's having those integration platforms to be able to take whatever data you've got and share it between systems.
Yeah, so a lot more IT principles coming into kind of that's where the edge is going. I mean, we haven't talked about edge computing. I mean, maybe we should talk a little bit about that as well. But a lot more of that happening sort of at the coalface rather than sort of back in the IT department that sort of moving around. It's becoming much more operational. So good points raised. All right, folks. So there's a few answers in there. I'd have to say David Robb is leading at this point with the closest. But if we're running out of time. So questions or answers to the number of Model Ts, we've got a little bit of time left. Excuse me. Okay. Let's go into that and see if there are any questions. I guess I've got quite a few. Maybe let's talk about edge computing and what it means to you guys, because that's certainly on the up in terms of conversations that are going on. What does it mean to you, Ronaldo?
For us, we actually also have our industrial IoT hardware, which is based on the edge computing unit model or concept. I think for us, it's been an enabler for us to do not have to rely on old technology. For example, so old production lines still run this like an old edge computing based on Windows, and you have some limitations. You have to share that computer with other tasks. But for us, we identified some bottlenecks in that scenario where we find that okay, we are an industrial 4.0 provider of solutions. So for us, it's going to be a key important point for us to have our solution come with our own hardware. So that's why we partner with companies to develop our own industrial IoT hardware that's become pre-configured with our software. And it's been very good so far in terms of how we can add value to their business and have their machinery connected to the internet, to the cloud, exploring all the new features that we have and automation that we can provide them with in a matter of weeks. Whereas in the past or other systems, it would take about 6 months to have anything connected, anything happening or running. So it's being able for us to do more, also to scale and have additional source of data that we can then transform into real-time information. So we used to have only connection with the PLC in the production lines. Now with our new edge computing, we are getting additional information via sensors, via barcode reader, and all that. So customers like because they can, once they start seeing how data that is then converted into information is important to them, give them the ability to make decisions based on facts, not assumptions or guesses. They start to ask for us to add more sensors, and because they can scale on demand, we can add 2 sensors, 4 sensors on a monthly basis, and we can just see what is the benefits out of the specific data points that we convert into information. I think it's been very good and critical for us to be in terms of where we are, and also be, as Kieran said, more like a future proof as well, and allow us to do more.
Oh, it's good to hear that it's actually something real, not just an idea.
Well, actually exists, and Kieran is building it.
Say that again, sorry.
It actually exists, and also Kieran was the one that built for us, and he's already working on the next models as well, the version 2.
Okay, so this is, I'll give you a floor for a plug. No, I won't, because I've got a question to address from Cameron. Just clarification of the difference between data and information in terms of manufacturing. Okay, so it's a pretty broad question, I guess, but into well, Kieran, you lead that one off.
Sure. Yeah, so the data is, or data, depending on if you're American or not, is a number, basically, 14. Information is, the fact that 14 is a temperature. It's 14 degrees. You've actually got more layers as well if you want to get into all the philosophical, historical baggage that comes with it. You have knowledge and wisdom as well. So knowledge is more around the fact that, okay, the temperature is, this is the temperature of that particular machine. And I know that the normal value is 15 degrees. And then wisdom is I guess, a little bit more more difficult to articulate, but it's more around the idea of got all of the historical knowledge of this too. So you know that it's 14, you know that it's got an average of 15, but you also know at this time of the day it does sit normally slightly below the average value that you'd see. So I guess it's just those, the different layers of data to wisdom, basically. And so what I always go on about is data, at the end of the day, is just numbers, and the more of it doesn't make things any better. You've really got to get into that information layer and up to make.
Yeah, I mean, to me, information is the context around the data. It puts it into context of why. Yes, you want the data and you need the data, but what do you want it for? What are you trying to achieve with it? And that's where you model the data, you interrogate the data to get the information out of it that is useful to you.
I agree. That's right. It applies to specific scenarios, environments, combining a multiple collection of data into information. Yeah, I think that's definitely agree with you, Simon.
I get the sense there's a lot of experimentation around data at the moment, and we're on a journey to finding the information that sort of leads to better decision making, which is probably the next step. down that pathway. All right, look, guys, that's fantastic. Thank you very much for your contributions. I have to just have a little thanks here for Syncom, who obviously made today's event possible. Syncom have got one of the leading CPQ software solutions, configure, price, quote. So they are all about converting the customer demand and essentially salespeople configuring their quote in order for the manufacturing or purchasing processes to kick into place. So reasonably mature on that. It plugs directly into the Microsoft Dynamics suite, but also has integration with other ERP and CRM solutions. They run out of Sydney. Contact details there, so have a look at what they offer. They also have Control ERP, which is a manufacturing solution, and for smaller manufacturing distributors, have Priority ERP under their suite as well. So take a look at them when you get a moment. They'll get in touch with you directly after the event as well. And yes, David, you're absolutely right. The 20 million was slightly ambitious, but not out of the ballpark. 15 million vehicles Henry Ford produced on those first manufacturing lines that kind of invented the whole category. Pretty impressive, really, and he really didn't do anything too wrong, but things have moved on since those days. But you do win the chocolate fish with your guess of 20 million. Okay, so as you exit the webinar today, there's a little web page that pops up and just prompts you for an exit survey. We'd love for you to fill that in, just to give us an idea of how you thought today went, any ideas for topics or different formats that you would like to see, and we'd love to hear from you. Thank you very much for your attendance today. Keep an eye out on iStart for upcoming Lunchbox events. Thank you again to Kieran, Ronaldo, and Simon for your time, and thanks for everyone for attending. I'll think things will wrap there. Thanks, guys.
Oh, thank you very much. It's been a pleasure.
Thank you. Cheers.
Okay, cheers.